All right, I'm not going to spend a whole lot of time. I think I say that with every time I start writing these videos. Let's see here. I turned one of the lights off. I think now we got a better, I want to say better field of view, because when I turn that on, then there's a couple of reflections. So I'm not going to cover anything from chapter 3. That was, again, atoms and moles. And then chapter 6 was electron dot diagrams. Chapter 7 was your naming of compounds and molar mass, percent composition, and then empirical and molecular formulas. I don't have the chemistry book with me, so I'm not going to try to make up any examples of doing those molecular and empirical formulas, because they just tend not to work out. We can show you how to work them, but they just don't come out to a nice even number like they do in your evaluations. So then we wrapped up with your balancing chemical reactions, which is what you have now. So I'm just going to go through perhaps parts of chapter 4, which was your Bohr models, electron configurations, and quantum numbers. I think last time we did 10. That was in the video that was made on Friday, and you can go back and look at that. Let's see here. That would be, so today's 13th, 14th, 15th. So that would be the 9th, I believe, okay, is when you could have went and saw that from Friday, okay? And let's see here. Let's maybe do a bigger element, maybe going all the way down to, and I think this periodic table is just a little different. This is from the organic and biochemistry book. Maybe there's one in the biology textbook, so hold that thought right here. And since it's so dark down here, I got a different example from physical science book. It's just a little bit bigger, a little bit easier to read for myself. So let's go ahead and take a look at, I just turn this on for just a moment. We'll do element 66, okay, which is element dy, okay. Okay, so element dy, element 66. So if we were going to do the Bohr model for that, okay, of course, here's your nucleus. You've got 66 protons in there. And if you follow along with your slide rule, all these numbers should add together to give us, again, 66. And perhaps when you go over these again, you can follow along even perhaps without the slide rule, just by looking at the periodic table. Okay, so 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, okay, 3d10. Make sure we remember the slide rule makes that correction for you. Then we've got 4p6, okay. Now we go up to 5s2, 4d10, okay. And then this is where perhaps it gets to be a little confusing. So we just did 5d10, okay. Now follow your slide rule again. After 5d10, I believe is 5p6. Then we're going to go out to the 6th energy level, 1, 2, 3, 4, 5. We do 6s2 according to your slide rule. Then we got to go all the way back down to the 4th energy level, and this can hold 14, okay? But we want to look at what column dy is in, and then that will tell us, okay, how many of those we're going to put in there. Okay, I'm just looking at this. I think we're all right. So we can perhaps, or per se, make a prediction here. We've got 6 S2 all the way out there, so there's 12. Okay, 1, 2, 3, 4. There's 24. Okay, then we've got those two, which is 20. Okay, so there is 6. So 4 and 5. So what this would tell us is this can hold 14 in this 4F14. Okay? There's 66 in the nucleus. We are up to 66. So the prediction that we can make is, as you look at the periodic table, dy should be in the 10th column. So then we're all the way down here into 4F14. So let's go ahead and take a peek at that quick. Should be 10 over. 1, 2, 3, 4, 5, 6, 7, 8, 9. But then don't forget, on your periodic table, you made that correction that way down here, okay, that's what sometimes gets to be so confusing. You've got to start with, what is that, Lawrencium and whatever element, gosh, I don't have my reading glasses with me. No, that's actinium, maybe. Element 57 is the Lawrencium. The one below that is AC, which is element 89. So you got to start with that one. So element 57. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. In the 10th column, so we had made that prediction because we are 10 away. So we go ahead and put 10 right here. I'll go ahead and put a box around that for later purposes. Okay, so that's the Bohr model for dy. Then, as we move forward from there, we had done an electron configuration. And with that, since this is 66, we picked the next lowest noble gas, which would be xenon, I believe. So that would be 54, okay? 54 is xenon, okay? And notice that we are 12 away, but following our slide rule, when we use that noble gas, we go ahead and look at the periodic table, and 1, 2, 3, 4, 5 is where xenon is, so 5p6 is full. So then go ahead and follow your slide rule down after 5p6, which means we need 6s2. And then after 6s2 is that 4f block that we're talking about here. Remember, we had a 14 there. It can hold 14, but we're only going to put those 10 in, so that's 4f10. So 10, 2, and 54 would give you 66, so that's got to be correct then. And then finally, the quantum numbers for that is N, L, M, and S. Okay? If you have a really good understanding of this, you really don't need to do this orbital diagram. You can probably just look right at this noble gas configuration and go ahead and pick out 2 of them right away. Okay? And if you're following along, I want you to think about which 2 of these we would expect that you would know right away. So if you said 4 and 3, that would be correct. Here's 4, that's N. And then this is a given value of 3, and this is why. Because remember, this can hold 14. And each one of those bus seats can hold 2. So that means how many horizontal lines will you put? Okay, if you had said 7, that would be correct. Okay, so this is the 4F block. Okay, so here's where the 4 comes from. This is a given value that the S block is 0, the L block is 1, the P block is, oh gosh, I got that wrong. The S block is 0, the P block is 1, the D block is 2, and then the F block is 3. So now we got to get these 2 values, okay? And then again, this is where our bus seat rule follows. Okay, we got 10 arrows to put in here into our bus seats. So we follow along. 1, 2, 3, 4, 5, 6, 7. So 8, 9, and 10. So put a little asterisk there because this is where we get our M value. Because M will equal whatever a negative L to a positive L would be. So the negative value of L is -3, -2, -1. We don't skip over 0, +1, +2, +3. And again, that last electron fell in here. So M is a -1. And since it's pointing down, S is a -1/2. Okay, so a little bit of a review of Chapter 4 there. Okay, so that's all I have. Wasn't going to spend a whole lot of time on this, so hopefully we'll be back in class tomorrow. I think there's a pretty good chance that that will happen, should we interpret what the weatherman says. But who knows? Maybe we'll be putting another one of these videos together. All right, that's all I have. We'll catch up to you next time.